Hello, welcome to a demo of the 5G standalone implementation in the 5G-VINNI Norway facility site. So the paradigm shift of 5G is about empowering the vertical industries. There are many reasons why standalone 5G being demoed here is needed for this vision. First, it is fundamental to support native network slicing. Second, support for real ultra-reliable low-latency communication will come with standalone 5G. Further, there are important features such as support for private networks and edge cloud, to mention some important ones. Here we see all the slices implemented in the 5G-VINNI Norway facility site so far. 3 of them are based on non-standalone 5G, basically using D-Core as a mechanism for slicing as in 4G. The focus of this demo is on the 2 slices based on standalone 5G. And it can be seen that slices based on standalone and non-standalone are running on the same cloud infrastructure, using the same transport network and the same radio access network. Here we see the infrastructure, and the NFV infrastructure and the hardware in the cloud is provided by Nokia, as you can see at the bottom here. And the container as a service layer based on Kubernetes is provided by Ericsson. On the top, we see the cloud native functions for the standalone 5G core. And further, we can group these into different clusters. And each cluster is placed into a separate security class so that they can get proper protection and isolation. When building the slices, we instantiate separate instances of the UPF, the AMF, and the SMF, as can be seen to the left. And these different instances go into different slices. And we can also see that the NRF, the NSSF, the AUSF, and so forth are shared between the 2 slices. In the access part, we started out by using a traffic simulator for testing, and now we have also connected to the 5G G-Node B from Ericsson to both the slices. One major change with 5G standalone is to move into a cloud-native architecture. So let's have a look into the Kubernetes view. So here we see the first Kubernetes clusters with all namespaces in one of the worker nodes. And if we look into one of the namespaces where the second UPF lies, we can see all its building blocks. And further, we can have a closer look at one of the pods in the namespace. And there we see on which worker node the pod is running. And we can also get the status of the resources used, such as the processors, memory, and so forth. And now let's connect the device to the standalone 5G. And here we see a device successfully connecting to the Ericsson 5G radio at Rikshospitalet in Oslo, which is indicated by the 5G symbol popping up in the upper part. And if we look into the operations manager, we can first look at the left graph, where we see that the device registers with the access mobility management function. And you can see how it goes from 0 to 1. And second, we can also look into the right graph that the device establishes a session with the SMF, being the session management function. And you can see how that also goes from 0 to 1. And in the bottom part there, again, we see the Kubernetes pods, which we also looked at in the Kubernetes view previously. Then, here we will show you a packet trace example when a user is redirected from slice 1 to slice 2, in which case the network slice selection function, the NSSF, facilitates this redirection. So, first, we see the initial registration request from a device, which is sent to the default AMF in slice 1. And since the slice ID does not match, a query is sent to the network slice selection function to find the appropriate AMF for the slice. And here we see the response from the network slice selection function pointing to AMF in slice 2. AMF1 then asks the 5G radio to redirect the packet to the appropriate AMF and slice. And then the 5G radio sends the registration request to the appropriate AMF, which is in slice 2. And further, we see how packets are sent to the correct slice. And the last thing I wanted to show you here is Graphana. Graphana is a neat open source tool used to monitor different parameters. And in the upper part, we see the number of devices registered to slice 1 and slice 2, which is counted from the AMF instances in each slice. And in the lower part, we see the number of sessions established to slice 1 and slice 2, being read from the SMF. And what we see here now is that first 10 users registers with the AMF, which you see on the top there, and secondly, they also establish sessions, which is in slice 2. And so this was a quite technical demo, and the next steps now are to provide services and slices using standalone 5G to different vertical industries that we are working with. So the smart port, the Norwegian Defense, factory of the future, and a hospital. So please stay tuned for more insight into this. Thank you so much for your attention.